Okay, so as we continue L'Hopital's rule here, here's the assignment from the other day, and this is question number 16, and the question was about infinite limits and how we kind of deal with infinite limits. So just a few things you want to remember. If we end up, if we plug infinity in, okay, now that, first of all, it doesn't really make sense, infinity is not a number, but if we consider what would happen here if x was getting very, very large, all right, something close to infinity squared minus 3 times something close to infinity, well, that's just going to be infinity, right? That's going to be infinity. And over here, infinity squared doesn't really make sense, but that's going to be infinity as well. So this is an indeterminate form, all right? There was this little thing that we talked about here, as n approaches infinity of 1 over n, right? And that limit is 0. So remember that one? So you might be able to use that, okay, in some of your questions. So that's something you want to remember. And of course, that's to any r, where r is greater than 0, I guess. Yep. Greater than 1. Anyways, usually we're talking about whole numbers here, but natural numbers for r. Anyways, back to this question. So if we're at this point here, let's apply L'Hopital's rule, and let's say that the derivative here, right, is going to be 10x minus 3, and over here is going to be 14x, right? If we plug infinity in to x values here, what do we get? Well, 10 times infinity minus 3, that's infinity. 14 times infinity, that's infinity. Okay, so let's do L'Hopital's rule again. Let's apply it one more time, see what happens. As the limit as x approaches infinity, take the derivative again, we get 10 over 14. Now there's no x, which is great. X can go wherever it wants, and what are we still left with? 10 over 14. So that's 5 over 7. That's your limit. That's your answer. Okay, so just keep applying L'Hopital's rule. I don't know if you remember from previous math classes, but as x approaches infinity here, really what we're talking about is what's the horizontal asymptote? Remember, if this was a function, horizontal asymptote? And so if x gets really large, what does the graph kind of go to? So if you had your calculator for this question and you were like, I don't know what's going on, you could just check your calculator out and it might give you an indication. Although you might not get right exactly to 5 over 7, this is still the best way, but you could sort of double check your answer. The other thing is, if you remember, when we have a rational function like this, and the question was, what is the horizontal asymptote? Then what you did as a shortcut before is you checked out the degrees of the function in the numerator and the function in the denominator. And there were a few little shortcuts that we studied. So if the degrees are the same, the horizontal asymptote is simply a ratio of the leading coefficients. And as a matter of fact, that's what we get here. See, 5 over 7. The other rules were if this degree on top was greater, if it was 3 or 4 or 5 or 10, and this was 2, then you have an asymptote that's not horizontal. It's an oblique or slant line asymptote. Okay, so you have something like this, a graph that looks like this or something. And if the degree on the top was less than the degree on the bottom, if it's just x and this is x squared, then the horizontal asymptote, or the limit here, would be just 0. Automatically just 0. So there was those 3 cases, and that's from previous math classes. We talked about those. So again, you can use that information to double check your answer. You can graph it, and then check out what the graph looks like. What's it approaching as x approaches 1,000 or 1,000,000,000 or whatever you want to plug in. Apply L'Hopital's rule, or remember your three little memory things, and I'll type them off on the side here about when you look at the degrees. So just as we summarize those points that we talked about here, just the shortcuts for you to remember might be a good idea to remember this. But if the degree of the numerator is equal to the degree of the denominator, then we have the limit as x approaches infinity is the ratio of the leading coefficients right here. So 2 over 3 would be your limit, 2/3. B, if the degree of the numerator is greater than the degree of the denominator, like in this example right here, the limit is infinity. So either positive infinity if everything is positive here, or it could be negative infinity as well. And I've graphed this just to show you. So 2x squared over 3x. If you graph that, it turns out to be a line. right? Because when you simplify this, and this is a really simple example, but 2x squared over 3x comes out to 2x over 3, right? So it's just sort of 2/3 x, if that's the equation. Then you have 2/3 x here, and it just keeps going up to positive infinity forever, so that's your limit. And if the degree is greater than the degree of the numerator, so degree of the denominator is greater, like this, then you have 0. And if we just go ahead and do this one, so that's 2x divided by 3x squared. And we'll delete the rest of that, wrap it around there. And you should see that we have this happening, and of course right around this area right here, that's approaching horizontal asymptote of 0, which means that as x approaches infinity, the y value is approaching 0. Okay, so L'Hopital's rule should confirm all of this. And yeah, it's just something you can remember when you're doing your tests or when you run into these questions, that all that should line up.